All right, today we're tackling a concept that feels so simple on the surface, but the deeper you go, the more it just breaks your brain. It's a concept that underpins reality itself, yet it seems to defy all common sense. We are diving headfirst into the mystery of infinity.
I mean, we use the word all the time, right? But what actually is it? It feels like something we should just get. But the more you stare at it, the weirder and slipperier it becomes.
So is it just a really, really big number? You know, the biggest number you can think of, and then just add 1? Is it some finish line way off in the distance that we can never quite reach? That's kind of the gut instinct, but it's not even close to the whole story.
What if infinity isn't a destination at all? What if it's a completely different kind of concept, one that plays by its own totally bizarre set of rules? Let's start peeling back the layers. To get started, we've got to go way back, like over 2,000 years ago, to a famous paradox from the Greek philosopher Zeno. It's a puzzle about something as simple as walking, but it shows you just how tricky infinity can be. Okay, picture this. You want to walk across a room. Seems easy enough. But to get to the other side, first, you have to get to the halfway point. Makes sense. No problem so far. Okay, so you're at the halfway point. Now, to finish the journey, you have to cross half of the distance that's left. So now you're 3/4 of the way across the room. Still with me? And from that spot, you still have to cross half of the tiny little bit of distance that's still left. I think you can see where this is going. You just keep covering half of what's left, over and over again, into smaller and smaller and smaller chunks. The thing is, this process never actually ends, because you can always divide what's left in half. So here's the kicker. If crossing the room means you have to complete an infinite number of tiny little journeys, how is movement even possible? How do you ever get there? This is Zeno's paradox, and it's a perfect example of how infinity just pops up where you least expect it. So Zeno's paradox is all about chopping something finite into infinite bits. But what happens if you start with something that's already infinite? Well, for that, we're going to check into a very, very strange hotel. Welcome to Hilbert's Grand Hotel. This place has an infinite number of rooms. Room 1, Room 2, Room 3, and on and on and on forever. And tonight, it is completely booked. Every single one of its infinite rooms has a guest. The no vacancy sign is lit up bright red, but then a new guest walks up to the front desk and asks for a room. Now, in any normal hotel, you'd just say, "Sorry, we're full." But this is Hilbert's Hotel, and here, the rules are different. Okay, get ready for this, because it's wild. The manager gets on the intercom and asks every single guest to please move one room down. The guest in room 1 moves to room 2, the guest in room 2 moves to room 3. You get the idea. Since there is no last room, everyone has a new room to move into. And boom, just like that, room 1 is now empty, ready for the new guest. We literally just made space in a hotel that was already infinitely full. So infinity can just absorb new members without breaking a sweat. But what if I told you that isn't even the weirdest part? Not even close. In the late 19th century, a mathematician named George Cantor came up with an idea that just shattered everyone's understanding of infinity. Cantor's idea sounds completely impossible, but it's been proven to be true. He showed that some infinite sets are genuinely, measurably bigger than other infinite sets. Yeah. Infinity comes in different sizes. He basically broke them into two main types. First, you have countable infinities. Think of the natural numbers, 1, 2, 3, 4, and so on. You could, at least in theory, list them all out in order. That's the kind of infinity we had at Hilbert's Hotel. But then you have uncountable infinities. Think of the real numbers. This includes all the decimals and fractions that live between the whole numbers. It's actually impossible to list them all. And here is the part that will absolutely melt your brain. Cantor proved that the number of points on just one tiny line segment, like all the real numbers between 0 and 1, is a larger type of infinity than the entire set of counting numbers going on forever. Just think about that for a second. So you might be sitting there thinking, okay, cool thought experiments, neat puzzles, but what's the point? Well, these strange ideas about infinity have massive implications for how we understand the very fabric of our universe. See, in physics, infinity isn't just a curiosity, it's an essential tool. It's crucial for theories that describe everything from the center of black holes to the Big Bang itself. Cosmologists use it to model the potential shape of the cosmos and to figure out the ultimate fate of our universe. So, yeah,
wrestling with these weird paradoxes isn't just some abstract math exercise. It's actually fundamental to our big quest to figure out where we came from and what the universe really is.
And that leaves us with one final, absolutely dizzying thought. If the universe we live in is truly spatially infinite, and there are only a finite number of ways that particles can be arranged, does that mean that somewhere way out there, there's another you, and another, maybe an infinite number of yous, all living out their lives? Now that is something to ponder.